Please welcome Professor Kazuhiro Kosuge.
For global prosperity and industrial automation. Okay, I hope clicker works. I was expecting to operate my PC here, but they don't have a clicker. Okay, let me start with the AI and the robotics. Okay, sometimes AI and the robotics is told as science and the systems, right? Science is curiosity-driven. Whenever we do some scientific research, we do that because we are interested in that. Science is curiosity-driven. Systems are goal-driven and designed and created for specific services by integrating different technologies, hardware and software. So these two, science and the systems, are completely different, but the AI and the robotics has both, characters. Especially robotic systems, as the previous speaker you have mentioned, have a physical interaction with the environment. We have a body, robot has a body, robot has a physical interaction with the environment. So that is a more important part when we are talking about robotics. And another one, very important thing is that we have no reason to develop an AI and robotic system if the system has no societal values. Okay? Since we are going to artificially create some system, it has to be good for human being. So that is a message I would like to say at the beginning. And when I was, many years ago, about 15 years ago, when I was working with the Japan Science Technology Agency, I had an opportunity to chair one workshop in which we are talking about how the societal robotics research at the time is related to the societal value. I asked them, what is the societal value? They say that for individuals, quality of life. For communities, industrial competitiveness. For the globe, global issues. So we discussed how the robotics foundations, AI is the same, could contribute to society through many examples. At that time, we have a lot of foundational robotics research going on, but we have no idea how to connect, how to link this foundational research to societal values. After a lot of discussions, we came to the conclusion that robotics can provide services, and through the service, the robotics technology, robotics research can contribute to the societal value. That is a discussion at the time. Now this year, JST again went back, revisited this topic, and they are talking about what is the current issue relating to the robotics and AI. And at that time, we found that we have so many services which we can create using robotics research. AI is the same, like global level, environmental monitoring, natural resource exploration and development, space exploration, deep undersea and underground exploration, anti-terrorism, rescue operation, prevention of infectious disease, and the government level. These are coming from our GDP list. Okay? So you may be familiar with that. Actually, robotics technology can contribute to the government service, AI also, agriculture, forestry, fishery, mining, everything. And concerned with the quality of life, you are talking about the healthcare issue, right? And we discussed a lot. This is the items which we found at that time. Now we may have more applications in the quality of life. Thus, we have a lot of applications, future, I would say, good things, for robots, and so that we can, so that the government is a reason to fund our research and development. And this is another one. Suppose that, we'd like to have an elderly care robot, for example. At that time, we are discussing a lot, and maybe what we like, the robot is a system. So we are trying to collect different technologies from existing technologies. But sometimes we don't have, necessary technologies, and we need to develop. Or sometimes existing technology may not be enough, so that we have to do research to enhance the existing technologies. In addition to that, we need some technology which is specific in this field. By through those research results, we can create a robotics research. Another more important item is that whenever we develop a new system, it has to be sustainable as a business. Otherwise, just research and development and curiosity-driven research are carried out. So sustainability as a business is also very important. So I also, of course, when I was young, I'm interested in a lot of things. I thought that a robot can do something for human being. And, we developed such a naive systems which can carry a large and heavy object together with humans. But sooner or later, we found that some simple tasks which could not be done by a human or humans could be done with assistive robot helpers. But unfortunately, general tasks could not be done easily, even with the assistive robot systems, because the robot does not know how to collaborate with a human. Okay? So in order to collaborate with the human, the robot has to know the task, what kind of task it's doing, its user's intention, what he or she would like to do, and how the user wants to be assisted. Actually, a lot of information are missing. Okay? So we decided to develop a dance partner robot for developing a mechanism for closer human-robot coordination and interaction. And what we did during this development is, So the key technology is how to read its partner's lead. This is a kind of human's intention, right? Estimation was the issue. So we developed a robot. I hope it works. And we had a demonstration in Aichi Expo. It's 2005. Long time ago. Okay. So this was taken by the older video. Resolution is not so good. But this is a female dance partner robot. I couldn't dance by myself. In ballroom dance, male dancer leads the dance. So female dancer lead, it's male dancer's lead. So that is a technology which we developed. And after that, I had an opportunity to visit the company, and many people are working like this. Okay? I thought that this worker is just walking around the under the vehicle. So I found that maybe we can, if a robot could provide a worker with necessary parts and tools, when he or she needs them, the worker could concentrate on the necessary and disassembly task. So we decided to develop a robot called Paddy. And the Paddy is a robot which delivers necessary parts and tools to a worker when he or she needs them, to reduce the worker's load, to improve the efficiency of the work, to prevent the mistakes of the work. And again, similar to the previous case, in order to help the worker, the robot has to know the task, the worker's intention, including the worker's behavior, and how the worker wants to be assisted, and so on. A lot of information is needed. Eventually, we developed a prototype system, and we bravely brought it into the actual factory, car factory, okay? And it turns out that by introducing this robot, they can reduce the working time of the worker or 20 to 30%. So they are so excited. So finally, we made it. The system, a little bit after the little bit modification, was installed in the factory. This is a sensor which detects a worker's position, and the robot now we change the control algorithm so that the worker can work more smoothly. And this is a part supply system for the robot. And after that, we still continuing the research, and by implementing today's machine learning scheme, without getting data in advance, we can utilize this robot. That is a recent version. So I would like to explain what I am doing now, what I'm interested in, and what I'm doing now. I'm interested in robotics and automation for garment production now. Let me explain why I'm interested in the garment production. You may know the global revenue in apparel market is expected to reach $2 trillion US in year 2028. This is amazing. But unfortunately, this is our 5 biggest users of industrial robots in 2019. China is the largest user, and they installed about 11,000 units per year in the year 2019. But only 157 robots are used for textiles. In Japan, among around less than 50,000 installations, only 13 robots are used for the textiles. Other countries, 0 at that time, year 2019. But going back to the textile apparel assembly, garment industries, actually, the 80% of total production time cost in apparel assembly is used for material handling. Okay, material handling is a field where that industrial robot is supposed to be used. Why we couldn't use it? But unfortunately, this is not so easy to handle. And again, another one is sewing is the most labor-intensive process in garment manufacturing. Actually, 67% of labor distribution is used for sewing. So we came to the conclusion that we have no reason to hesitate to get into this field. Okay, as you may know, you may not know, this is before I was born, unfortunately. In 1946, ENIAC, the world's first electric digital computer, was unveiled, right? And the same year, George Devol developed the magnetic controller playback device for factory automation. And in 1954, George Devol designed a programmable robot for universal automation. And its patent was granted in 1961, and industrial robots have been brought into the market since around 1960, 1961. But this time, okay, this is original idea is a programmable robot for universal automation. So he carefully designed a robot. You can Google the original patent. And that is to control the object of some rigid object position and orientation by programming the motion of the robot. But if you'd like to control the fabric, for example, fabric shape is not fixed. So it's very difficult to control this flexible fabric, a flexible object. That's the reason why you have some difficulties to do that. And actually, in many, today's industrial robots has a lot of, still many manufacturing processes exist which are difficult to automate using robots. And the garment industry, the handling of the garment is one of them. As you know, garment production is, consists of a lot of difficult processes. And of course, in 1980s and 1990s, in UK, there are several works carried out regarding the, how to automate the garment production. And some of the concepts have been utilized in the semi-automated garment production robot system in these days. Okay, so the next one is I'm going to show you what kind of result we have done so far. Most recent version. For, as I mentioned, usually in the garment production process, several layers of fabric are cut together So we need to separate it one by one. So for that purpose, we developed a very simple system. This is a passive actuator-less gripper. We call it PAL gripper. Is a passive actuator-less means no actuator is installed inside. So the relative motion between the finger and this housing causes a motion of close and open of the fabric. And we can pick up one by one from the stack of the fabric. Okay, next one is another one. Sometimes we need to precisely position the fabric. Like this is a color part, and this is the interlining, usually used for the color. So in this case, we designed different types of and you may feel that this is easy, but okay, when picking up the top fabric, several fabrics are stuck together. So the robot has to know where is the first topmost fabric is located. So for vision system, we are using AI scheme. And okay, concerned with sewing, this is a sewing system currently used in many manufacturers, many factories. This is called a pattern sewer. So in order to sew the flexible fabric, they have to, using a template, they make it solid. And by controlling the motion of this plate, sewing is realized. So we decided to do a fixture-free 2D sewing. We wanted to make something so that we can sew two fabrics together without using fixtures. Okay, this is first one is if the sewing line can be printed on the fabric, top fabric, the system can follow the top fabric so that stitching can be done without using fixtures. Another one is in this case, a sewing line or desired seam is defined relative to the outer edge of the fabric. So in this case, we are just using only the head of the sewing machine. First, next one is more interesting. Looks like we designed something for the existing sewing system, and this is unpublished, most recent results. You will see. And of course, we have a vision system, we have a robot system in coordination, and through which we can sew two pieces of fabric together. Actually, this is a color part, and so that, okay. Yeah, my PhD student recently developed this one, so I thought one more slides and one more videos. I hope it will be more interesting. This is for 2D sewing. Another one is a 3D sewing. Sometimes we'd like to create a 3D shape, right? The 3D shape can be created by sewing upper fabric and lower fabric along a different sewing line. This is a conceptual model, and this is really good. Let's see. Now, this is real time, so no speed up. This is no fake. This is real. And actually, this is a kind of a fabric of the car seat. And you will see that I would like to fast forward, but I couldn't operate my computer, so it takes a bit time, sorry. Because this machine doesn't have an automatic thread cutting system, so we have to do that. So this is the most recent version of our fixture-free 3D sewing. Okay, conclusion. Current AI cannot provide a complete solution for robots for real-world challenges, of course. current robot hardware does not provide sufficient dexterity for real-world challenges. But what is important, as the previous speaker mentioned, AI is a valuable tool for robot applications that address real-world challenges that traditional methods cannot solve. I'm sure that the AI will enable the difficult task of handling the soft materials, in this case fabrics, for future garment manufacturing automation. Thank you very much for your kind attention. Thank you very much.